Right.
All right.
You haven't made a single calculus video in this class.
I'm now, here we go, right? Right. All right, so this is the test prep for Unit 5. Let's look at question 1 together. Hey, me. You have it in front of you? Number 1. At time t equals 3 seconds, the acceleration of an object is negative 7.3 feet per second squared. I'm going to circle it. I'm going to put a box around the key word. I'm going to circle it. The object's velocity, box it, 30 feet per second, circle it. Use local linearization to approximate the velocity of the object at t equals 3.5. So I'm going to put a box around local linearization. Do you remember what that lesson was about, local linearization? Or do I need to remind you? Local linearization means that you create a line. Linearization, right? A tangent line. And that's what you use. You don't use any other thing. You just use that line to calculate whatever you're calculating. And there's 3 things you need to know when you do that line. So I need to know what x equals, what y equals, and what the slope equals. Now, in this situation, we don't have an x. Instead, we have a t. And we know what t equals. T equals 3. Same idea. For y, we'll come back to it. And for the slope, we're going to come back to it. So, the other things I boxed was velocity and what? Acceleration. How are they connected with calculus? Acceleration and velocity. So, if I know the velocity and I take the derivative, right? The derivative means the same as what? So when I take the derivative of the velocity, you get acceleration. That means the same as slope. And what number do you get? So guess what the slope is? Do you see how we fought, right? Thought through that, fought through that? What still don't I have written down yet? So remember, we're approximating the what? The velocity, right? So the y is what the velocity is. Not the time, but what the actual velocity is. So what did I circle I haven't used yet? That's really like your y coordinate. Can you write a line using those 3 numbers? Go for it. Now the question doesn't end there. What did the question really ask is to use that line to approximate at what t value? And it's okay you went from t to x. That's fine. So with this equation, I'm going to switch the letters around. So velocity at 3.5 using local linearization would be negative 7.3, 3.5, take away 3, plus 30. If this was free response, you would leave it there. But the only thing you need to make sure you add to it is the units for velocity, which is... Now, let's pretend it's multiple choice. Could you use your calculator to get an actual value that you can match with the answer choice, right? On multiple choice? So turn on your calculator. I'm going to type in negative 7.3, parentheses, 3.5, take away 3, parentheses, plus 30. Now, if I press enter, the way it looks, and everybody needs to practice with this new calculator, you're going to get a fraction, right? If I need that answer as a decimal, you press Control and enter, and now it's a decimal. So what's the answer as a decimal? 26.35 what? Feet per second.
If you want a fraction,
Then you just press enter. So do you notice above, the fraction is above? They're the same number. One's a fraction and one's a decimal. So if I just want the exact answer, just press enter. If I want that answer as a decimal, you press Control and enter. So then you can switch back and forth. Is that cool?
Yes.
All right, let's read number 2. Are you ready for number 2?
Yes.
1 point on this curve is 2, 4. Use a tangent line. So we have an equation. I'm going to box it. We have a point. I'm going to box it. Use a tangent line to approximate the y-coordinate when x is 2.01. So another way to say local linearization is just to say the word tangent line. It's the same lesson. So what do I need again? X. Can you tell me what x equals? 2. We're not going to make that complicated. Oh. What does y equal?
4.
Yay. What don't I know that I need to find out? Now, the slope is, in calculus, the derivative at that number, correct? Now, I'm going to show you, I think, the most efficient way to do it. You ready? I'm going to actually go to the graph. And particularly because I've not done this with you before, it's good to get to the graph. So how I got to the graph, see that shaky calculator? That just means toggle back and forth between graph and calculate. If you ever want to erase something quick, press the menu button, go Actions, and then delete all. And then
Wait, what?
Menu, Actions, delete all, and then you're just starting from scratch again, right? Now, I actually don't care about the graph. Listen to me. But what I'm really doing is defining something where then I can take the derivative. So what I'm going to do is press the tab button. Do you see the tab button underneath the shaky calculator? Do you see F1 at x pops up? We're going to type in the equation. Now, here's something else that may be helpful or not. You can do a fraction by pressing Control and divide. So Control and divide, do you see that fraction line that pops up? So 1, I know. Every time we get to use it, we'll learn a little more, okay? So I'm typing in 1/4 x to the 4th. Do you know where the exponent button is? See that arrow that goes up beside the x squared? That allows you to put a power in there. All right, I'm going to press enter. Now, it graphed it. I don't really care about the graph. But what I do care about is now it's defined in my calculator. So I'm going to go back and press the shaky calculator again. I'm going to type in F. Do you see I have a keyboard underneath? F1. And I'm going to use the underneath pi. Do you see that comma? It's really an apostrophe. Wait a second. Let me back up. So what I'm going to do is this. Sorry. I'm going to press menu. Not menu. That's not what I wanted. I wanted the one beside the 9. So do you remember beside the book? Is that? Which one of those means derivative? Do you know?
Oh, dx. The d. Next to
the GM
the second class and second row.
Do you see that one? The next one beside it is the second derivative. So do you see that highlighted one? I'm going to press enter. Now I'm going to type in F 1, parentheses. Now, where do we want to find the derivative? At what number? At what x value? So 2. So what's the derivative at 2? 0. So if I wanted to find the derivative at a different number, by the way, if you ever want to edit it, you have to go back and press enter. You got to highlight it back again. See how you highlight it back again? You press enter and then you can go back and you can change it. Oh, it's not doing what I want it to do. Bad. It's not doing what I want it to do. Okay, so let's go back to the graph. All right, let's go back to the graph then. I thought I could do it that way, so my apologies. Do you know how to go back to the graph again? So the shaky calculator. See the graph? Press menu. Do you see number 6 that says Analyze Graph? Which one do you think I want out of those numbers? The derivative, which is 6, right? And then do you see how it says position? So we're going to type in the number 2 and press enter. Where do you see the answer that pops up? Do you see it there? Now, do you see that hand that opens up? You can move that hand, press the middle pad until you see the hand close. So press it down, the hand will close. Do you see that close? Can you make the hand close? So put the hand over the 8, close it by holding down the cursor button in the middle, and then you can move that number and then press it again, and then it releases it. So it could grab and release. What happens in this calculator is that numbers start to overlap, and you can't see it. You want to try it again? Okay, go over the 8. See the hand when you go over the 8? Press it down. Do you see it close? Then, once it's closed, you can put it anywhere you want, wherever it is you want, press it again, and then it releases it. So what was the answer that we needed? 8. Let's try it again. You ready? I want to find the derivative at a different number. We're just practicing right now, not with the question. Ready? So if I wanted to find the derivative at 4, using 4, what would you do? So let's try it. So menu, then what? And then what number would you press for the derivative? 6. And then it says position, which means what x value. We said we'll change it to 4, right? And then press enter. Now the answer's there, right? But can you see it right near the origin? So can you put your hand over the answer so you can see it better? Grab it. I'm going to move this to the left, just for fun. And then when you release it, what's the answer? 64. Now, I can also do this. Notice my scale is insane, right? It goes to 1,000, negative 923. Press menu. Do you see number 4 that says the window or zoom? If you press standard, see number 5? That's 10 by 10 by 10 by 10. That's standard. So if I press 5, it's now 10 in all directions. And isn't it a nicer looking graph when it's in standard mode? So you can see it. Do you want to try that one more time to find the derivative? Using a graph? Okay. Try it when the answer is 3. 3. Can you try it? What's the derivative at x equals 3? So you have the function in. What do I press first? Then where do I go to? And then the derivative. And then what number do I put in for the position? 3, and then enter. And then do you see the answer there? Now in this case, see the graph? The answer is actually what number? And if you want to move 27 around, you can. But the answer is 27. See, what it did was, it went to the point on the graph when x is equal to 3. Do you see that? When x is equal to 2, do you see there's a different point? So when x was 2, what was the derivative? When x was 3, what was the derivative?
27.
When it was 4, what was the derivative?
64.
Get what I'm saying?
It's x cubed.
Huh?
It's x cubed.
Did I type it in wrong?
What do you mean?
Huh?
What do you mean?
What do you mean x cubed?
That's the derivative of
You're right. Like if you just did the derivative of it, it would just be x cubed, and you can see that relationship, right? Because 2 cubed is, got it, 3 cubed is, and so on. Awesome. That is great that you saw it. All right. So I realized that we haven't practiced enough with our calculator. Was that worthwhile to look at? Okay. So all that is saying, what does m equal here? What number? 8. That's right. It didn't do what I wanted it to do. Dang it. Know what I mean? The calculator says, I understand like certain language, and you didn't type it in right. So you got the wrong answer. But I wanted it to work that way. But I didn't give up, so I tried it a different way. All right, we're not done. The tangent line is y equals slope x minus 2 plus 4. And then what number do I plug in for x? And then, if this was free response, would you go any further?
No.
But if it was multiple choice, what would the answer be? Use your calculator. So this would be 8 times 0.01 plus 4. Do you know what 8 times 0.01 is? It is 0.08 plus 4 is 4.08, right? So this could be multiple choice. This would be free response. What would happen if this was not a calculator question? No calculator. What would you have done? No. What would you have to do with this equation? You'd have to just do the power rule, right? Is taking the derivative of this difficult?
No.
So 4 times 1/4 is
1.
and then subtract 1 from the exponent, and it would be. So really, y, the derivative of y is just what? Could you plug 2 in and get 2 cubed, which is 8, and do it without a calculator?
Yeah.
So with a calculator, without a calculator, right? We have skill. Okay, number 3. A large rectangle is divided up into 8 equal cages for an FFA exhibit. If there is 1,600 feet, so we have 8 equal cages, 1,600 feet of chain link, fence to use, find the dimensions of the large rectangle, that would be the large rectangle, so that a maximum area is enclosed. So here are some key words, right? So first of all, do you recognize this being an optimization question?
Yeah.
That means you're finding a relative maximum using calculus, but with a word problem. Okay, I need a primary, and I need probably a secondary. You ready? So for the primary, what you underlined was the question. Find the dimensions of the large rectangle so there's a maximum what? Area. So if these are 8 equal cages, I need some letters in here. So I'm going to let this be X and this be that be Y. And the reason I do it this way, because if I ask you what's the area, you go length times width. So how many Y's and how many X's would you be multiplying? So I'm going to write that right here. So what does area equal? How many X's? And how many Y's? right? That's an area one, right? We obviously, and we're going to write this nicer before I go any further. That just means 2 times 4 is 8x, y. Excellent. Obviously, I can't have x and y. I need one variable. So I need a secondary. So what other number did I circle? 1600 has to do with the perimeter, right? How much fencing you need? Be careful. How many x's and how many y's do you need for perimeter?
4 and 8. Oh, we need more.
Every partition, right,
Yeah.
needs chain. What would you do? So how many x's? 1, 2, 3, 4. Can you go with me? 5, 6, 7, 8? How many? 10 x's.
Jesus.
No, it's okay. 10 is not that bad of a number. How many y's? Be careful. 1, 2, 3, 4 in the middle. 5, 6, 7, 8 on the top. 9, 10, 11, 12. Okay. So how many x's and how many y's? Thank you. Now, we actually know what the perimeter is. We have how many feet of fence? 1600. So it doesn't matter to me which one you solve for. So let's say you wanted to solve for y, because eventually I'm going to let you use your calculator anyways through this kind of question. Do you know what y would equal? Like, how would you get y by itself? You would 1600, right? Subtract what? And then what would you divide by at the end? That's what y would equal. So we're going to come back to this equation right here, which was 8xy, correct? And where there's a y, what am I going to put in? Now, we're going to take what of that? Good. Let's use our calculator. This one, I promise you, is a calculator-based question that you get to do this with. So, can you go back to calculate? Can you press the button that takes us to derivative, which is right beside the 9? And then, let's do this right this time. So, we're taking the derivative with respect to x, and then we're going to type in, be careful here, I'm going to go 8x times. If you just go 8x parentheses, it won't understand what you're doing. It needs to know that you're multiplying. One parentheses is not an operation. If you want to put parentheses around the 8x, now it understands it with 2 parentheses touching each other. Now it's multiplying. But with only 1 parentheses, it needs 8x times. Now you can do parentheses. Remember the fraction button? Can you press that fraction button? What's going to go on top? What answer did you get? Okay, let's write that down. Even when you use a calculator, you still have to write down each significant step. So understand that you took the derivative using your calculator. Is that good? Then what am I going to do to find the maximum? Excellent. Do you know that this calculator solves equations? So I'm going to show you. Yes, way. So we are going to press menu. Can you do that? Number 3 says algebra. When you solve an equation, that's algebra. And then do you see the number 1 says solve? So we're going to type in the equation. Remember the fraction button? So it's 3200 over what? 3. Subtract. Again, I'm going to do a fraction. 40x over 3. And then I'm going to make it equal to 0. The only thing is I need comma x at the end. And the comma is right below the pi. So underneath the pi is a comma. That tells the calculator to solve for x. Type it in. Do you know where the comma came from? What answer did you get? You're welcome. Now, if you want to know if it's a maximum at 80, what would you plug in? So if you had a number line, and we know x can't be 0 or negative, so from 0 on, and you had 80, right? How could I know if 80 is a maximum? What would you do? Now, we don't need a calculator for this. If I put in 1 for x, can you see the answer is going to be positive? Because 3,200 is bigger than, obviously, 40. And if you put in a number bigger than 80, because 40 times 80 is 3,200, right? That this answer would be, so did it create a maximum? All right, what did we just solve for? X or y, obviously? Do you remember what the question said at the beginning? The dimensions. So what would the dimensions be of the big rectangle? Okay, how many x's make that width right there? So it would be 80 and 80. So one dimension would be 160 feet. Now, do I need to know y? Yes. How can I find what y equals? What would I put in? Which equation would I use? For y. Can you use your calculator and tell me what y equals when x is 80? So again, good practice, right? If you get to use your calculator, darn it, right? You're going to use it. So, control divide, 1,600, subtract 10 times, what again? 80? 12. You get 200 divided by 3. We're just going to write down the exact answer. Because, so we're not going to write down a decimal if we don't have to. That is not, it goes on forever. We're not going to round for no reason. But that y, how many y's do I have that make up the big rectangle? So to that answer, what am I going to multiply it times? And now what's the answer? 800 over 3. So what are the dimensions here? 160 feet by 800 over 3 feet. And we're avoiding rounding if we don't have to. Isn't it nice to know how to use your calculator? And notice I still showed each significant step, right? Like I showed like the primary, the secondary. I showed I took the derivative equal to 0. I solved it, right? All good? Number 4. For questions 1 through 3, I didn't leave a lot of space. And then I started to leave space to answer it. So I'm sorry about that. That's why this is being crowded. But number 4 is actually a really quick question. So what do you see for number 4 is the derivative. Do you see that? It says f at 2 equals what number? 5. And then it says find what f at 5 equals. So what this is called is a starting value problem. And the value starts at what number? Write it down. So we write down 5. And then the derivative tells me I'm either going to add a number to 5 or I'm going to subtract. And how I know is finding the area under the curve. So how I know, ultimately what I'm doing to figure out what I do is to integrate from 2 to 5. And when you're integrating, one way to integrate is to find the area. Do you notice the area is above the x-axis? That means you are adding. If it was below, you would be subtracting. So do you see from 2 to 5? In order to integrate this, we need to find the area. Can you find the area? By the way, what shape do you see there from 2 to 5? Do you know how to find the area of a trapezoid? It's just like a triangle, except there's 2 bases. So it's 1/2 How long is one base? 3. How long is the other base? 2. And then what's the height? 2. That's a great answer, and you could end right there if it was free response. If it was not free response, 5 plus 2 is 5 plus 2 is 7. Half of 7 is 3.5. And when you add it together, it would be so I'm adding this area. So what was our starting value again? 5. And then this tells me whether it increased or decreased and by how much? 3 plus 2 is 5. I totally am doing this wrong, aren't I? 3 plus 2 is 5. 5 times 2 is 10. Half of 10 is, and 5 plus 5, duh. All right, number 5. I know, right? How hypocritical of me, Mr. Gertson. Get a load, right? Number 5. In number 5, you're given an integration with limits, a definite integral. If you go from 0 to 1, what's the answer? If I go from 0 to 4, what's the answer? If I go from 0 to 5, what's the answer? And from 4 to 5, what's the answer? Okay. Can you tell me what the answer would be from 1 to 4 by using those numbers? First, if I went 0 to 4, what's the answer? I'm going to take the whole thing from 0 to 4, and the answer is -2, and I subtract, what is it just from 0 to 1? And by that, it gives me the answer. So, from 0 to 4 is what number? And then you subtract 0 to 1, and guess what you're left with? 1 to 4. Okay, let's try this again. Now, this time we're going from 0 to 4, but we have two functions. One is f and the other is, so from 0 to 4 for f, what's the answer? Subtract. From 0 to 4 for g, well, I don't know 0 to 4 yet. So 0 to 5 is 10. 4 to 5 is, so subtract, and what you're left with is, and you subtract them, and you get the answer, -8.
Would you ever add, or would you always subtract?
In these scenarios, you would add if at first they give you the whole thing, and then you have to subtract, and what remains is what you're looking for. They could give you a situation where you have to add the two parts together to get the whole one you're looking for.
Like it would be like b was a plus?
Yeah, but let's say that you had to figure out what the answer is. If I gave you different information, so if I knew from 0 to 1, and I knew from 1 to 2, and I said, what's 0 to 2? You would add the two together to figure out 0 to 2. In this situation, you're given the whole integration, and you're asked to find part of it. So you take the whole thing, subtract what you know, and what remains is what you're looking for. Number 6. Okay, the graph below is the derivative. Do you see that? At what x values is there a relative maximum and minimum and point of inflection? So, if you have a derivative, the x-intercepts is what we look at. That's when the derivative is equal to 0. At -3, it goes from positive to what? Does that create a maximum or minimum? Positive to negative, that's a relative max. Where's another x-intercept? It goes from negative to, so what happens when x equals 0? Negative to positive, it creates a, can you see the difference between the two? At 4, we don't have a max or minimum. Do you know why 4 is different? It doesn't change signs, right? It just touches. At x equals negative 1, do you know what we have? That's right. That's because for a velocity, or for a derivative, we change from decreasing to increasing. Do you know where else there's a point of inflection? At x equals 2. And where else? All of these are, what's the difference between a relative max or a point of inflection when you're looking at a derivative graph? So a max or min, do you see the x-intercept? If it crosses over, it creates a max or a... Do you see the when it goes from decreasing to increasing? Or vice versa? Increasing to decreasing? So when you look at the max or mins on a derivative graph, what does that give you? The point of inflection. All right, number 7. When using the method U substitution to evaluate 6 to 12, 2x over the square root of x plus 1 dx, it says you complete the correct substitution when u equals what? So for u substitution, they started it off for you. I then need to know what x equals. What does x equal if u equals x plus 1? Then take the derivative. And what would the substitution look like? Well, first of all, the limits would change. How would I find the u limit? If x is 6, 6 plus 1 is? If x is 12, 12 plus 1 is? Instead of x, what does x equal? Instead of the square root of x plus 1, what would go in there? But if I didn't write it as a fraction, what would it look like? You could also see the substitution and then you would have a du at the end. Either one you could see, right? So could you do u substitution and just show the substitution? That's it. It doesn't tell me, oh, now it says what? Complete the integration. So how do I then take this and integrate? Well, step 1 is to do some algebra. So we're going to distribute. So 2 times u is 2u. In fact, you know what we're going to do to make life easier? We're going to put the 2 in front. One of the properties of integration is a constant can be a scalar, that multiple scalar can be put in front. And then I can just distribute with u's. Remember there's an invisible 1 here? So when you multiply, you add exponents. So when I multiply that together and add them, you get u to the positive half. If I take negative 1 times that, I get negative u to the negative a half. Now I integrate. So you can keep the 2 out front. Do you know how to integrate this? Add 1 to the exponent, and what do you get? And then what would you divide by? Which is the same as, right? So you would divide by that exponent, but dividing by a fraction means the same as multiplying times the reciprocal, minus. Can you add 1 to the exponent? What would you get? 1/2. Dividing by a half means the same as times 2, and we are integrating from 7 to, I don't need to go back to x. So from 7 to 13. If this was free response, we would end right here. We'd plug in what first? So we still have a 2 in front. So I'm going to plug in 2/3. Nope. For a definite integral, we don't need to go back to x. We rewrote it in terms of u, and we're just staying with it. So first you plug in what number? And then what number do you plug in? Not 13, but 7. And then let it go. All right, Elsa? Let it go. Notice there's no candy here because it's a definite integral. And I have no desire to go any further than that. So when you see a problem like that, it's not going to be a multiple choice likely. So I'm going to let that go right there. And that's the right, correct, and answer. Yes?
How do you know when to change the numbers on the integration?
So when you do a U substitution, you also have to change then the limits, the upper and lower limit, using that right there. So if I want to know what U equals for the limits, you plug in the X values to get what the U would equal. And that means I don't have extra steps plugging X back in at the end. It saves me time, and you get the same answer. Turn the page. All right, can you integrate the following? A is an anti-chain rule. So what I'm going to do, and I'm not going to make it difficult, is what's the derivative of the base? 6x. That should be the hook. So I'm going to write down what it should be. But it wasn't that. So what number in front keeps it the same? You take what it was, which was 2, divided by what it became, which was 6. So what was the hook given in the problem? 2x. But what did I need? 6x. So I wrote down what I needed, and then the number in front keeps it equivalent. So if I multiply them together, you still get the answer 2. How did I get 2 over 6? What it was over what it became. Yay? Now we can integrate. When you integrate, remember this hook you came up with it? Pretend now that it's not there. And just do the anti-power rule, which means what? Add 1 to the exponent, and it's now what? Divide by, and what do I still have in front? Done. Don't simplify. And of course, why am I including the candy? These are indefinite, right? There's no limits on these. B is algebra. Then calculus. What do I mean by that? So, when I look at B, do you see 4x squared?
Yeah.
Do you know the square root of 4 is 2? And then the exponent on x, the power is 3, and the denominator is 2. That the square root of x cubed can be written as a fraction. The power goes on the top. Square root means the denominator is 2. Now I can do algebra. What's 4 divided by 2? And then when you divide, you subtract the exponents. 2 take away 1.5. What does that give me? Now I can integrate it. How do I integrate this? Add 1 to the exponent, and you get 3 over 2. Divide, which means the reciprocal, and we still have a 2 in front. Done. Add 1 to the exponent, divide, which is the reciprocal, and we still have a 2 in front, and then the candy. C. This one is going to be a U substitution. That's because the derivative of x is 1, but I have an x in front. So I'm going to write down, in fact, I'm going to do it on a different piece of paper because I'm going to run out of room here. So for C, I'm just going to do it on a different piece of paper because I know I need more room. U is going to equal what? X equals U minus 1. The derivative of X is equal to du. We're going to go back into the problem. We don't have limits, so we don't have to change the limits. Where there's an X in front, X is U minus 1. X plus 1 is U. Do you know how to do cube root as a fraction? And then dx is du. We're now going to distribute. What's the invisible exponent that you don't see on U? So when you multiply, you add. You need to know what 1 plus a third is. 4 thirds. And then 1 times anything is just what it is. I have not integrated yet. I've just done substitution and algebra. Now, to integrate, what's the power rule? What do I do to 4 thirds? Which is 3. So it's 7 over, and then that makes this 3 over 7. Minus, again, add 1. That's 3. 1 plus 3 is 4 thirds. And then divide, which means the reciprocal, and don't forget the. And then the last step, you have to put x back in. So u is equal to.
So only indefinite you add it back in?
Yes.
Okay.
Indefinite. Definite means you have limits.
Okay.
And again, as we're going through this, some of you are just copying and not thinking as well as you could. I will put a blank copy that you can go through this again. Maria?
Why did you put u to 1/3?
Because it was the cube root. Do you see in the question that cute little 3 in there?
Yeah.
To write that as a fraction is 1/3. If it said square root, the fraction would be 1/2. If it said 4th root, the fraction would be 1/4. Yeah? If it was 5th root, the fraction would be 1/5. Yay? Pretend like that. You see the pattern.
No,
Do you see why it's 1/3 now?
no, I'm not asking like 1/3. I'm just asking why did you put u?
Why did I use U substitution?
No, just why did you put u?
I don't know what you mean. Like, why did I just have U in there?
Yeah.
Because what is U equal?
X.
So I took out the x plus 1 and just put in U.
Okay.
That allows me to do algebra, so then I can do calculus, and then go back in. Bro?
I just want to know, I got u/4/3.
How did I get 4 over 3? I added 1 to the exponent. So the rule of the integration for the power rule, add 1 and then divide. So do you know how to add 1/3 plus 1? What do you need? Common denominators. So 1 will be 3 over 3. What's 1 plus 3? That's where 4 thirds comes from. Got it. D. D, is it definite or indefinite? D. Has limits. This is not a trick. It's that easy. Can you integrate 3x squared? What would I add to the exponent? I would add what to the exponent?
1.
What happens when you go 3 divided by 3? What am I left with in front? How about the next one? Integrate 2x. What do you get? Integrate 2x. X squared and 2 divided by 2, just, hey, how do I know I did it right? Take the derivative. What's the derivative of x cubed? What's the derivative of x squared? Can you see how you can quickly tell? Because it's a definite integral, draw a vertical line. And on the ends, you put the limits, which is -1 to we are first going to plug in what number? Then what number am I going to plug in? And you subtract the answers. We do not need to go any further than this. Oh, make sure I'm writing it right there. This should be a 2. So, if this is free response, what would you do? Stop. If it was not free response, this isn't hard. 27, take away 9. 18. How about here? Negative 1 cubed. Negative 1 cubed is negative 1. Subtract positive 1. What's negative 1? Subtract positive 1. Negative 2. Negative 1 subtract negative 1. Or subtract positive 1. So you get 20. But that would only be necessary if it was multiple choice. You had to find the answer that matched it. E is algebra. Do you know that the square root of x means the same as x to the 1/2? Square root of x means x to the 1/2. So I write it in a way where I can do exponent laws. What are the exponent laws? If you're multiplying u, add the exponent. So the exponent on x that is invisible is 1. So 1/2 plus 1. I still haven't integrated yet. 1/2 plus 1/2 is just x to the 1. I don't need the 1 there. Minus x to the 1/2 times 3 is 3x to the 1/2 dx. Now we can integrate. So again, what's the rule of integration? Add 1. What would you get? 2 over 2. So 3 plus 2 is, divide means times the reciprocal. How about x? What's the integration? 1/2 x. Correct? X, the exponent you don't see is add 1 and you get, and divide. And by the way, when you take the derivative of 1/2 x squared, you get x. Next, add 1 to 1/2. 3 over 2. And we already have a 3 in front, and to that 3 we need 2/3. Plus the candy. You could write this, the 3's cross out, right? So you could just write this as negative 2. F. Can you do the algebra so you can get to the calculus? Here we go. That 2x divides every term. What's 4 divided by 2? Subtract the exponents and it's x to the 1. Keep going. What's 1 divided by 2? That's negative 1/2. And the x's cross out. And the last one, that again is 1 over 2. But what exponent is on the x? Because it stays in the denominator, it's to the negative 1. Now, after you do algebra, can you now do the calculus? Integrate 2x. What do you get? X squared. Integrate negative 1/2. And what do you get? Negative 1/2 x. And how can you tell again? Is you can take the derivative, right? Integrate. What happens? This is a special one, right? So I'm going to just give you the answer. It's ln x. And then the candy. Well, I bet you.
Are you going to put that on test?
Just for fun, maybe. No, I don't think so.
Yeah, you are.
I quit.
You know what the big point of this question was? And I didn't go all the way through to recognize it's a special. And what makes it special is when you add 1, you get to exponent 0. Is I wanted to see, can you actually do the algebra to get to the calculus? That's what I was practicing. And by the way, if you type this in your calculator, let's say it was a calculator question, you could do it, right? And you get the answer. All right, this one, easy again. Can you integrate this? There's no algebra. Just get right to the calculus. What would you do with the exponent? What's 8 divided by 4? How could you double check that you did it correctly? So 4 times 2 is 8 and subtract 1 to the exponent. Hey, what's the derivative, or what's the integration of negative 2? And I'm integrating from what to what? So first you're going to plug in the upper limit. Subtract, and then you plug in the lower limit. And that's a great answer. You let it go. So you integrate, then you plug in the upper limit, you plug in the lower limit, and subtract the answers. I'm not going to do the next step, but if you had to, you could find the answer, and subtract. H. Number 9. Or H first. Hey, this is the absolute value. Shh. To integrate absolute value, there's no algebra. We need to graph it. To graph it, we're going to take what's inside the absolute value, make it equal to, solve it. Where is the vertex for this? When x equals what? So we're going to graph this. When x equals 1 is right there. What's the other end? 2. So the end point at 2, what's 2 take away 1? And the absolute value of 1 is 1. So there's the right end of the v. What other number do I need to plug in? Negative 4. Negative 4 take away 1 is, and the absolute value of negative 5 is 5. So at negative 4, the answer is 5. Do you see that absolute value right there? And I only drew it from negative 4 to 2. What I need you to see is, I'm going to fight through this because you need this video. And you can't act obnoxious through it like you're going too fast or this or that. You've got to have to pick up the pace and think with it. How many triangles are there here? Are they both above?
Yes.
How do you find the area of a triangle? Okay, the base here is 1, 2, 3, 4, 5. And the height of that big triangle is also 5. We're adding, because the other triangle is also above. But that's just a cute little one. That's 1 by 1. That's done. Okay, number 9. Find h at x if f at g at x equals that, and you're given some information. So, yeah. Now, this is really just the chain rule. So if I want to know the derivative of this, you take the derivative of the outside, and then the hook is the derivative of the inside. The chain rule. The derivative of the outside times the derivative of the inside. And then, what number do you plug in for x? You plug in 3. Now you need the rest of the question. G at 3 equals what number? G at 3 equals, so inside, what number did I put in? 4. What's G prime at 3? That number would be, one more time, you need to work and not giggle through the video. You should appreciate this so you can pass this test. F prime at 4. What does it give you? So the end answer is 2 times 5, which equals, so I'm going to recap. We took the derivative by doing the chain rule. What is the chain rule? The derivative of the outside times the derivative of the inside. This is the hook, right? Then, what number is for x? I did that. Then all I do is go back in and plug numbers in. What's G at 3 equal? 4. See how I put in a 4? What's G prime at 3? 5. There it is. What's F prime at 4? And then I finished it. Okay? Just one little step at a time. There's no math there that's overly complicated. Just knowing how to do it. 10. Hey, the mean value theorem. Just in case you forgot, the mean value theorem says, where does IROC equal? It says find the values that satisfy the mean value theorem from 4 to what? 9. So there's a few things I need to find. First, to find slope, it's y2 minus y1 and x2 minus x1. What that would be the AROC, right? Average rate of change, the slope formula.
Yes, sir.
Now, what I do know are the x values. What are the x values you're subtracting? 9 take away, which just equals... What are the y values? I don't know them yet. So if I plug in 9, 2 times 9, subtract the square root of 9, what do you get? 18 take away 3, which is... What other number do I need to plug in is 4. 2 times 4, subtract the square root of 4. So that's 8 take away 2, which is... So 15 take away 6 is 9. So the AROC equals what? 9 over 5. So we're going to write 9 over 5. That's AROC, right? IROC is derivative. What's the derivative of 2x? What's the derivative of root x? If you do this enough, right, eventually it will like hit you in the head. This is x to what exponent? So, when you take the derivative, it's 1/2 x and subtract 1, which is negative a half. You're not integrating, you're taking the derivative. So 1/2 times in front and subtract 1 to the exponent. Now, this is what we need to solve, right? Okay, use your calculator. Or do you rather solve it a different way? Do you remember how to use your calculator to solve this equation? Menu, algebra, and solve. And I'm going to type in the fraction 9 over 5 equals 2 subtract 1/2. And then it's x to the exponent, and I'm going to use a fraction in the exponent, negative 1 over 2, comma x.
That's right.
Double check, make sure it matches, right? 9 over 5 equals 2 subtract 1/2 x to the negative a half. Solve for x. And what answer do you get? Look at it carefully, please. It is a skill to know how to use your calculator. So I get 25 over. The last thing you need to check is 25 over 4 in my interval? Is that number between 4 and 9? 4 goes into 25. 6 point something. So it's in between, right? 4 and 9. There's your answer. Done. Number 11. The population of a herd of moose. So I got 15 minutes. The population of a herd of moose is modeled by this function, which is 2,000 plus 200 sine, so on, plus 90 sine, and so on. So make sure your calculator is in radians. Can you sketch a graph of this? We're going to do this together. You're not going to give up. You're not going to pretend you're exhausted. Let's go. Get it done.
Say it louder. I want to hear you.
Now, if you press the on button or the home button with a little house there, you can change if it's in radians or not. What button do you think I would press next to see if it's in radians? And then the document settings, number 2. And then what do you see right away? It's in radians, right? Could you change it if it's not in radians right now? Is anyone's calculator not in radians? 8, repeat. What did I press first? So I'm going to press OK here. Can you get to that screen? What did I press to get to that screen? The home or the on button. Then I pressed settings. Then I pressed document settings. And the second box there tells me what it's in, right? Is yours in radians? All right. Now press enter for OK. Press that toggle for the calculator. We're going to go back to calculate. So actually we want to sketch it, right? So I'm sorry. So let's go back here. The graph. Do you already have a graph right there? Yes. How do I get rid of that graph? I'm just going to go menu, actions, and delete all. Okay. Press tab, and you're going to type this in carefully. $2,000 plus 200. Oops. Plus 200. Sine. Do you know where your trig button is there on the left? Sine. It's on the left beside the equal sign. Do you know the pi over 6? That would be there. Pi button on the left, bottom left. Over 6. Move the cursor. Parentheses. We're going to use x instead of t. So go x, subtract 3, parentheses, plus 90, trig button, sine. Again, it is at pi over 6. Oops. Parentheses, x subtract 3, and then close it.
Mr. Richard, you forgot to add another after the 2 sign and then the pi over 6 that's meant.
Let's see. I think I put it in there. You don't think I did? So,
Input, really?
I gotta just go to the menu and go Yeah, as soon as they go to
Mine says R. Mine says
Menu, if I need to go back,
rel X Y. It doesn't say F Y.
but tab then's going to create a,
go to Windows. Go to Windows.
what's that?
Go to Windows.
Go to the window?
Yeah. Okay, go to menu, window, and go to fit.
Right. But she's thinking that I typed it in wrong.
Oh,
And so I was trying to retype it in.
tab,
I did tab.
and then okay. I should take it back.
Oh, there you go. So let's see how I did. So you think,
After x minus 3, the first one you would go into another parenthesis to close that one in. With the sign.
all right, you're right. All right, so if you typed it incorrect, Stephen gave us a great clue to press menu, then window, and then do you see one that says to fit the data?
Yeah.
A. Now, do you see what we see, right? The problem is here is that I need to go from t equals, in this case it's x, equals what number? 0, and I want to do a whole year. So actually it's not going to go to 12, it's actually going to go to 11 because it's a whole year. So what I'm going to do is I'm going to go back to menu. I'm going to go to this zoom window, and I'm going to change my settings. So my x minimum is 0. And, oops, I need to also change my window and my window settings so that the next one goes from 0 to what number? 11. Now, do you see that graph that we came up with?
Yeah.
We're going to sketch it right here. Now, what window settings did I use? So you said window settings? Go back to menu and window and your settings. And what x values did I use? I went from 0 to what? 0 to 11. And do you know what I used for y? The y value at the bottom, that's divided by something, right?
Yeah.
See that number up there? I don't like that number. What would happen if I traced it? Do you see that number? Do you see what the points that I'm creating there? So what would be a good window? That y value? Like about 2300? What do you think a low y value would be? So the upper y value is 2300. The lower y value? Good luck, yeah. See you. So the lower one would be about The lower one would be about 1,700. So, can you see the moose population in terms of that?
What's the plural of moose?
Still moose.
Still moose?
How many moose are in the herd on August 1st? So for August 1st, normally you'd say 8th month, but we started at 0, so it's really going to be 7. So we're going to go back. We don't have a lot of time, so I'm not going to do anything but finish this question that you will see on the test. So if I want to find a value here to analyze the graph,
What about chocolate?
here, let's go back this way. I can actually go back and just calculate it by typing F1 parentheses 7 and approximately how many moose are there on that day? 2,251. So I got out of the graph, F1 has been defined, so I can just plug in 7. It says, when are there 2,251 moose? We just did it, right? Do you remember how to take a derivative? So, let's go back to the graph. We're going to go Menu, Analyze. We're going to press Derivative, and then 5. And what's the derivative at 5? 75.921. You can truncate. So in the settings menu, you can change how many decimals your calculator shows. So where we saw where radians was, you can go back. It's called float. And you can change that to a bigger number, and that gives you more decimals. The word is float. So when you go back to the settings menu, float, you change that number to a higher number. It changes the number of decimals you see. Explain the meaning of the answer to the derivative. It says explain the meaning of this derivative. That means on August 1st, the moose herd is increasing by a rate of 75.921. And T ultimately represents months. So that's like moose per month. So what did you learn with that derivative? Is the moose herd increasing or decreasing on that date? And how much is it increasing by? By almost 76 moose. You'd have to round, but in this case you don't have to. Number 12. Integrate from 0 to 2, negative 4, if f at x is an odd function from negative 2 to 2. If f at x is an odd function, that means whatever is above is the same that's below. So if you have one area that's negative 4, if it's an odd function from negative 2 to 2, then the other area is the exact opposite. In other words, you would have to go negative 4 plus 4, so you would have the same area above as you would have below. They'd cancel out and give you the answer 0. If it was an even function, you would double the answer. Because an even function would be like a parabola, right? And whatever area is below, right, would be the same area on the both sides, and you would, even means you double. Odd would mean it equals 0. So because it's odd, it's going to equal 0. All right, 13. Can you take the derivative using the quotient rule? What's the quotient rule? The bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. And it says take the derivative at what number? 1. Now, all you would have to do here is to plug in 1 and then let it go. And recognize even at 1, it's actually undefined, the derivative. So you could say the derivative is undefined. You could also leave it like that. But most importantly, do you remember the quotient rule? Do you know why it's undefined, by the way? Yeah. So this answer is undefined. But if it was an answer that was not undefined, you just plug in whatever the number is and then let it go. Don't have to evaluate it further.
You get extra points.
No, you can only lose points. That's the problem. Because if you evaluate it wrong, now points are taken away. What is the greatest possible area possible for a rectangle with this length and that width? Do you know that the area of a rectangle is length times? So if you plug in the length, 3x minus x squared, and the width, which is 3x, what's the greatest area possible? Step 1 is algebra. So distribute 9x squared minus 3x cubed. Take the derivative. That's 18x minus 2 times 9, right? 3 times 3 is 9. X squared, make it equal to 0. You'd solve this by factoring. Ultimately, the answer would be 2. And then you'd plug it back in. All right. I will finish this during my break. All this will be uploaded on YouTube for you to study.